Hello students, today we will discuss about graph theory, okay, which will come into B.Sc part 3 mathematics. Okay, so some introduction about graph theory. So definition of, of graph theory, a graph theory G is a collection of vertices and edges. Okay, graph means collection of vertices and edges is called graph. Okay, basically it is denoted by G is equal to V comma E, where V stands for vertices and E stands for edges. So let us define the vertices meaning and the edges. Vertices mean point. Vertices means points like this. Okay, so which I represent here. So vertices A, B, C, D and E are my vertices, that means point, and edges means line joined by that particular vertices. Okay, okay, line joined by that particular vertices. This entire line is called edges, and whole this representation is called graph. Now we will see about terminology. In this case, the incident, adjacent and isolated we will discuss. Okay, so for these three things we need to define one more graph like this. Okay, here it is one graph that we have vertices like this. This is my vertices and I will join like this thing. Okay, and this is one independent. So I will give the name A, D and E. Okay, so this is my one of graph. So let us define what mean by the incident. Okay, so incidents mean and B is this line X. So I'll just define the edge, this edge like X, and X is my incident between A and B. So I'll define like this: X is an incident of A and B. Okay, X is an incident of A and B. So what about the adjacent? Adjacent means one point joining or connected with how many points, or one vertex is connected with other vertices with how many ways. That means we need to define adjacent. Adjacent, here it is, we can define A is the adjacent of B and B is the adjacent of A, E, C. Okay, E is adjacent of C and D, sorry B, and C is adjacent of B and E, not A, because C is not directly connected to A, so we can't define C is adjacent to A. So here it is some example. Okay, A is adjacent of B, B is adjacent of A, E, C. Okay, so B is independently connected with all these vertices, so we can say B is adjacent of A, E, C. And the last point is isolated. Isolated means independent. So here it is, how many vertices are 1, 2, 3, 4 and 5. In between these 5, this is one isolated. Okay, independent. This is not connected with any other vertices. That point or that vertices we can say isolated vertices. So we will define here D is an isolated vertices. Okay, so these are the terminology of graph. Okay, top graph. So first type is directed graph. First type is directed graph. Okay, The meaning of this type is graph which have the direction is called directed graph. Let us see one example. We have three vertices like A, B, C, A, B, C. Okay, and joining by this some edges like this. Okay, so I will just directed this. Okay, so here it is. If I consider edge E1 like this, E1, that means edge 1, edge 2 and edge 3. Okay, so in this case the entire graph represent like E1 is equal to B comma C. Okay, where E2 is defined like this, E2 is defined like this, A comma B, E3 is defined like this, B comma A. Okay, so which means that here we can say B is our tail and C is our head of this edge. Okay, so starting point will be tail and end point will be head like this. So by this conclusion E2 is also starting, so I will just write first A is tail, B is head, again same, B is tail, A is head for E3 edge. Okay, that type of representation we can call directed graph. Now the next is we can define undirected graph. Undirected graph. Okay, undirected means graph which don't have direction. Okay, so I will represent same example like ABC are my vertices with these edges like this, same. Okay, so here we can travel like this, anything with. Okay, so edge E1, E2 and E3 and points vertices are A, B, C. These are my vertices, and this. Okay, so this graph don't have any direction on its edges. So that type of representation we can say undirected graph. Okay, in this you can represent like this also. Okay, there are in no tail or head like this, B or C you can represent, or C or B you can represent like this. e2 is E2 is B or A or A or B. There are no limitation on this because this graph is undirected graph. I hope you clear both these concepts. Okay, so now we will see about an XY walk in a graph of a sequence. Okay, that means the XY walk sequence. Okay, so generally we can represent XY walk like W is equal to, let us say X is on our starting point. Okay, X E1 V1, E2 V2, E3 V3, E4 like this, and so on, Vn minus 1 En and the last Y. This sequence is called XY walk. Okay, let us see one example about this example. Okay, so let us represent X is my starting point and E1 is edge 1, vertices A, E2 is my edge 2, vertices B, E3 is my edge 3 and last is end point. Okay, so how we going to represent this graph? Let us this X edge E1, this is my B and this is my Y. Okay, so how we going to represent this? This is my starting point X, this is my vertices A, vertices B and end point Y. and here it is, these are my age 1, age 2 and age 3. Okay, the sequence like this: x, e1a, e2b, e3y. This entire walk is called xy walk in a graph. Okay, I hope you clear this all these concepts from introduction of graph theory, terminologies, types of graphs, and also xy walk in a graph. So I hope you clear this. Okay, the remaining part we will discuss in the next videos, and thank you for watching. Thank you.